Caution, as we are badly in need of 6 marks for our quality assessment, please bear with us for the next few minutes.
Today we are going to see power MOSFET. MOSFET or metal oxide semiconductor field effect transistor is a 3-layer, 3-terminal, 3-junction voltage control device. The diagram here shows the basic structure of a power MOSFET and consequently shown is the symbol of a MOSFET. There are two types of MOSFETs, namely enhancement type and depletion type. The basic type which we are going to see today is enhancement type MOSFET. An enhancement type MOSFET is the one in which the channel is not created and it will be induced by sending a pulse. The diagram here shows the circuit diagram of a power MOSFET, and the figure B here shows the transfer characteristics of a power MOSFET. The transfer characteristics shows the variation of drain current ID as a function of gate source voltage VGS. Let us now move on to see the working of a power MOSFET. The diagram here will give us a clear outline as to how a power MOSFET works. When the gate circuit voltage is 0, the N and P junctions are reverse biased and no current flows from drain to source. When gate terminal is made positive with respect to source, an electric field is established and electrons form N channel in the P regions as shown in the diagram here. So a current from drain to source is established, which is indicated by the arrows shown here. When gate voltage is increased, the current ID also increases, which is already expected. That is the expected behavior of a MOSFET. And so this consequently, with this we can say the device is turned on. Now we are going to see the various merits of a power MOSFET. A power MOSFET has the highest input impedance, it has lower switching loss, it has a positive temperature coefficient, and a secondary breakdown doesn't occur in a power MOSFET. The applications of a power MOSFET is varied, which includes amplifiers, choppers, linear voltage regulation, inverters, and SMPS.
MOS control thyristor is basically a thyristor with two MOSFETs built into the gate structure. One MOSFET is used for turning on the MCT and the other for turning off the device. In MCT, anode is the reference with respect to which all gate signals are applied. The basic structure of an MCT cell is shown here. The equivalent circuit of MCT is here. It consists of one ON-FET, one OFF-FET and two transistors. One ON-FET, a P-channel MOSFET and the other OFF-FET and N-channel MOSFET represents MOS gate structure of MCT. The two transistors in the equivalent circuit indicate that there is regenerative feedback in the MCT just as it is in an ordinary thyristor. An MCT is turned on by a negative voltage pulse at the gate with respect to the anode and is turned off by a positive voltage pulse. Now let's look into the turn on process. MCT is turned on by applying a negative voltage pulse at the gate with respect to anode. MCT must be initially forward biased and then only a negative voltage be applied. With ON-FET on, current begins to flow from anode A through ON-FET and then as the base current and emitter current of NPN transistor and then to cathode K. This turns on NPN transistor. As a result, collector current begins to flow in NPN transistor. As OFF-FET is off, this collector current of NPN transistor acts as the base current of PNP transistor. Subsequently, PNP transistor is also turned on. Once both the transistor are on, regenerative action of the connection scheme takes place and thyristor or MCT is turned on. Now the turn off process. Offset is energized by positive voltage pulse at the gate. With application of positive voltage pulse, offset is turned on and ON-FET is turned off. After OFF-FET is turned on, emitter base terminal of PNP transistor are short circuited by OFF-FET. Now anode current begins to flow through OFF-FET and therefore base current of PNP transistor begins to decrease. Collector current of PNP transistor that forms the base current of NPN transistor also begins to decrease. So, base current of both PNP and NPN transistor does not have stored charges in their P and N bases. So, they begin to decay. This regenerative action eventually turns off the MCT. And MCT has many advantages. Low forward conduction drop, fast turn on and turn off times, low switching losses, and high gate input impedance, which allows simpler design of drive circuits. Main disadvantage of MCT is its low reverse voltage blocking capability.
மனித உயிரின் அவனை கிளம்ப பஞ்சம் ஜாக்கிரதை. அவளை கிளம்ப பஞ்சம் வேண்டாம். மனுஷ உயிரோட விளையாடாதீங்க. அப்புறம் நான் சொல்ல மாட்டேன்.